Okay, good news. My fear that I was muted in the last video was overblown. I was not muted. Um, Bad news. When I cussed because I thought I muted and lost a half hour of work, that's going to still be in the video. And I'm just going to leave it. I'll just give a little trigger warning at the beginning of the video that if you don't like harsh language that starts with S and has 4 letters, then you better end the video a little early. Um, Maybe mark it PG-13 instead of PG. It'll be fine. So on we go. We attempted to solve our first triangle, but it had no solution. So we move on to the next one, and we see how it goes. So here's one. Yeah, okay. So this is another quote unquote easy one. Excuse me, quote unquote easy one. I say it's easy because we mark angle B. It's 47 degrees. I don't know why I said B degrees. 47 puts me like here-ish. B is 21 and A is only 8. So what case did we call it? We called this case 4, the case where the opposite side is much longer than the other one. In fact, let's actually shorten this so we can try to draw this thing a little more to scale. 21 is like 3 times longer than this is. So 1, 2, like it should reach maybe way out to there. So that's like 21. Anyway, drawing this to scale is somewhat useful because if that's B, if this is 8, then over here is angle A. So up here is angle C. We can see that angle C is going to be pretty darned obtuse, right? And it's nice to know that going in, that you're expecting a big obtuse angle over there. So that's 47. Okay, let's go. There's going to be only one solution. And what do we already know going in? How do you guys want to see this? I'm not sure. Let's maybe do all the angles. Angle A, angle B, angle C. Then we need side A, side B, side C. So of course there's the 3 things we already know, which is that angle B was 47 degrees. Side A was 8 units long and side B was 21 units long. So we can see that we just need those other 3 things. So we're going to need the measure of angle A, measure of angle C, measure of side C. Okay, whatever. Hopefully that makes sense to you guys. This right here would represent the solution to our triangle, all 6 parts. 3 of them we already know, 3 that we now have to begin trying to find for ourselves. The good news is with all of these ASS problems, you are always going to have a side and an angle that are opposite from each other. And as we talked about ad nauseum in the last homework, was that's going to mean that we can use law of sines. So we can do the sine of the given 47-degree angle divided by the opposite side, which is the 21. And we know that we can set that equal to the sine of somebody divided by somebody. The only other thing we have is that 8. So we know that we can take the 8 and use it to find the measure of angle A, which is looking to me like it's going to be pretty small, right? It's going to be a small angle. So substituting in, the 8 would go into the denominator, and up here would be angle A. So we solve by cross multiplication. Not even cross multiplication. It might here just multiply by 8, right? And multiply by 8. You get the 8s to cancel. And you can see that now the sine of A is going to equal 8 sine 47 divided by 21. So do that math. You know what? Let me do it with you on my calculator. There we go. Clear all this garbage. You heard me. I said clear. Yeah, clear. Oh, I see what's happening. Clear. Okay, great. 8 sine 47 divided by 21. All right, I'm hitting enter. That gives me this decimal. And we know now that to solve for a, we want the inverse sign of that. So inverse sign of second answer, we want the whole thing. I'm getting 16.177, which feels right to me. We were expecting a small angle. It's pretty small. Share the flip chart again. So we now know the decimal we got was 0.2786. And when we did the inverse sign of that, I'll show all this work. I'm not sure it's necessary to, but 0.2786 ... That gave us an A that was approximately 16.177. So that gets plugged in here. Degrees. Okay, awesome. So now we know that we can easily find the next angle because they all have to add up to 180. So in our calculator, we can do 180 minus. Two ways to do this. You could either use parentheses and do the sum of these things. So the sum of second answer and 47. Enter. Another way to do this is just go 180 minus the 16.177, 318, and then just hit minus again, right? It's not going to be 180 minus this plus this unless you use parentheses. Distributing the negative, you can just say, well, I want to do 180 minus the angle and then minus the other angle. However you want to type it, I don't care. Just type it right so you get the right answer. So there's the same answer. The one's the 116.8226. So 116.823. Okay, awesome. So now to find the next one, we simply do the law of sines again, because now that we know angle C, we've got that, we've got angle C, so we can find side C by setting up another sine ratio. So so there's the orange stuff. We use the red stuff again to establish our second ratio. It'll be the sine of the given angle, 47, divided by the given opposite side of 21. So we solve, cross multiply. It's going to be 21 sine 116.823. That's going to get divided by sine 47. That'll give us C. So let's do that in our calculator. Nice. All right, so let's go back to a time when that was the answer in our calculator. You'll now just type in 21 sine. Don't forget to use second answer so you get the full expansion of that angle. And then you divide it by sine 47. And you're done. That'll give you the answer. 25.624. And that's it. So that's the one unique solution to this triangle. And again, there was only one solution because the 21 was greater than the 8. So we're done. We move on. Okay, 136. I think we talked about this. This is no solution. Because if you give me that obtuse angle, that's A, and then you tell me that side B is 28, and then you tell me to stick a 15 unit long thing on the end of it, not going to happen. No solution. So that's case like case 5. It's way down on the list. I'm not going to go back to it. All right, another one. This one was no solution again, because again, I already talked about this. Talk about it again, I guess. We got this obtuse angle, and then the one side that you're given here is 7. Super psych. 12. The 12 goes here. And so then side C is left, stuck there again. It's not long enough. It is shorter than 12. So no matter how we try to angle it, it's not going to fit because it's only 7. No solution. Okay, so yeah, there was a million problems here, but there's 2 no solutions in a row, so it's not so bad. Here's 31. I gotta sneak. Oh, this isn't ASS. Nice. So because this is, what is it? Since these guys have the same name, this side would not fall between these angles. So it's not ASA, it's AAS. Not that it matters. Either way, we know that we'll have one unique solution. So, okay, sketch it out. Yoink. Put a B over here, put a C over here. 42 is going to go like this. Whoa. And C is going to be 39. So it's going to go, whoa. And you'll notice they cross somewhere and define a triangle. So we were given that C is 18. So we can put an 18 over here. They didn't say what the other side was called, but it's got to be called A. It always is. So, okay, we're going to have one solution. And again, we would like to know the measure of angle A, the measure of angle B, the measure of angle C, the length of side A, the length of side B, length of side C. 3 of these things are already known to us. The other 3 we have to calculate ourselves. We were given B at 42 degrees, C at 39 degrees, and side C at 18 units. So that's 3 unknowns. Shoink. So we need angle A, we need side A, we need side B. And I'm hoping by now it has sunk in that the easiest thing in the world is finding the third angle when you've already got 2. So we know that really fast we can find angle A up here. By the way, at this point, I would erase all this extra garbage. So we're finding angle A, and it is as easy as doing 180 minus the 42 minus the 39. So what's that going to be? 180 minus 81. So it'll be 99. Yeah, it'll be 99. So that's measure of angle A. Okay, neat. So now that we've got the 99, what can we do from there? Well, right from the get-go, we had our side and our opposite angle, both of which were known. So actually, before we found the 99, if we really wanted to, we could have found side B because we had angle B. So we could have used law of sines to go get side B if we wanted to. I chose to find angle A first instead, which means at this moment we have the freedom to either find side A or find side B. It's up to us, and it doesn't matter which. Let's find side A, because who cares? We know we're going to take these green things, though, and write our first sine ratio. We'll say that the sine of the 39, when divided by 18, has to give the same result as when we divide the orange things. So the sine of 99 divided by I don't know what. So that's our variable. We solve by cross multiplication. So cross multiplying the A, I get A times sine 39. So we know we're going to divide by sine 39. So it'll be 18 sine 99 divided by sine 39. which I am calculating as something. Sine 39, 28.250. Okay, sweet. Now just do it again. Still going to grab these green parts and say that the sine of 39 when divided by 18 is going to equal, this time the purple parts, the sine of 42 divided by side B. So this math will all shake out in basically the exact same way. We'll go, okay, B times sine 39, it'll equal 18 times sine 42. So it gets divided by sine 39. So B will be approximately 42 divided by sine 39, 19.139. That's it. I have solved for all 6 parts of this triangle that has only one solution. Let's try 32. Now, how many more are there? 32, 33, 34. Okay, maybe I can do this. I've got 20 minutes before I've got to leave. So 32. Oh, piece of cake. Would you look at that? It's another angle side problem. So it's going to have only one solution again, and it's going to be virtually identical. Angle side. Yeah, so it's going to be like literally identical. So much so that I really don't want to do it, but the second I don't do it, someone's going to ask me about it. So I'll just do it. But I'm going to do it really fast. And I'm not going to draw the picture to scale either. Deal with that. Okay. So you know you got to find A. You know you got to find angle C. And you know you got to find side C. What are we finding first? We can find a lot of stuff, like we saw in the last problem. If you wanted to, you could find side A right now. I'm going to do that. Just keep it interesting. So we've got our mint green with our mint green. And then we've got the pink that we want, the pink that we know, so we can set up our sine ratio and solve. Sine 47 over 22 would equal sine 19 over A, which means A will be 22 sine 19 divided by sine 47. Sine 19 divided by sine of 47. 9.793. Okay, so now we bump into that problem again where I don't know this angle and I don't know this side. So how can I write a sine ratio? Oh, well, you can find the angle because all the angles have to add up to 180. So that's the trick. We got to find the angle first. So the measure of angle C has to equal 180 minus the sum of the other two, 19 and 47. That, of course, adds up to 563. So that's 117. Boink. And we're done. That's actually an answer. 117 goes in right here. Not only is that an answer, but it also allows us to use our law of signs again. We're sticking with the 47 and the 22, like always. Setting that equal to the sine of our newly found angle, 117, divided by the length of side C. So side C is going to be, if I cross multiply, that'll put a C right here. It'll put a 22 right there. And then we see that to solve for C, we divide by sine 47. Don't you dare show your work like this either, by the way. I'll be enraged. That is not how you show work. But I don't care anymore because this is the exact same as the last problem. So what are we getting? 22 sine 117 divided by blah, blah, blah. Divided by sine 47. 26.803. There, all done. Triangle solved. 33. Okay, so we're back to ASS. We know we're back to ASS because I only see one angle and two sides, and I do see that one of the given sides has the same name as the given angle. So we're back to having to test, are we? 48 is the opposite side. That's shorter than 49. Yeah, so we're basically guaranteed that this is going to be two solutions. Sketch it out. You'll see why. If you sketch this out, you've got that 75-degree angle, which is pretty steep. That's C. Then if we were to find the height, the side opposite from C is 48. This side's only 49. Oh my Lord, my brain. That's 49. 48 is just so close to 49 that, I mean, this thing is going to be less than 48. You know it is. Do the math anyway. Our height is going to be 49 times the sine of 75. $47.330. So that does tell me that our opposite side, side C, is greater than this, but it's also less than B. So we do fall into case number 3, the case where we have two solutions. This is our ambiguous case. So let me shrink all this malarkey. Put it over there. Here's what's about to happen. We have to solve this triangle. So there's going to be a solution named triangle 1. And triangle 1 is going to need the measure of angle B. It's going to need the measure of angle A. And it's going to need the length of side A. But then there's going to be another solution, triangle 2. And it's going to need a measure for angle B and a measure for angle A and a side A. Okay, so we've got our work cut out for us. We know exactly what we're trying to do. Shrink this malarkey. Okay, let's get down to it. I've already got my sketch. I kind of wish I hadn't shrunk that at this point, but we'll sketch it out again. I'd like to think I explained that we're always going to be finding the solution first where the unnamed angle No, the named angle. We have C with C, then we have side B. So the side opposite from that, we're going to be solving for the case where that angle is acute, meaning if we let our side swing in versus if we let our side swing out. These are my two triangles. The two triangles I'm talking about are this little sliver here. He's always going to be the one you solve for second. The one where angle B, the one where the angle opposite from the other given side is obtuse, that'll be our second case. Now, this orange triangle, the one that features this whole thing, that's the triangle where our angle B is acute. That's going to be case 1. So you might want to sketch that out and mark it up. We've got C, B, up here I guess is A. We know that C is 75. We know that C is 48. We know that B is 49. So now we're off and running. Looking at this, the only thing we can do is use an angle on a side to write a sine ratio, and then use the 49 to get at B. We can't do anything else. We can't do anything with A yet because we don't have enough info. We have to find B first. So we'll say sine 75. Oh, that shouldn't be green. That was supposed to be lavender. But that ratio equals the ratio of the greens, which would be sine of our unknown angle B divided by 49. Okay, so you better solve. I think I'm going to be looking at sine of B that equals 49 sine 75 divided by 48. That means the sine of B is equal to some decimal, 49 sine 75 divided by 48, 0.986 049 ... So that means B is the inverse sine of that, 80.418. That's going to slide into case 1. Okay, neat. Now guess what? Now that we've got angle B, we can go find angle A, because again, all three angles add up to 180. So we just use the triangle sum theorem. Okay, so add 75 to the answer we just had, subtract 180, 24.582. And so that means that now, of course, since we have angle A, we can find side A by just setting up another sine ratio, setting it equal to the lavender parts that we had in the beginning. So again, we'll go sine of 75 divided by 48. And we know that that ratio has to equal the ratio of the pink parts, where in pink we know the angle to be 24.582. And we do not know the opposite side, which is called A. So we're solving. Cross multiply, you'll get A times sine 75. So you'll divide by sine 75. So the 48 sine 24.582, that'll be in our numerator. Our denominator will be the sine 75. Remember that this stuff here is sitting in your calculator, so use the second answer feature to be nice and accurate. So 48 sine second answer, enter, divided by sine 75. 20.672. All right, that shouldn't have been bad. The question is, how now do I get to my second solution? And I tried to talk about this in class. We sort of ran out of time, but the idea is these angle B's, right? This is angle B from triangle 1. It's the acute version of angle B. But there's some other version of angle B over here, living inside this skinny green triangle. That would be our B2, the B from case 2. And I hope we said in class that there's this other triangle sitting here, maybe in purple. And they're both made out of side C, right? This side here was 48 units long. And if I swing that back in, this side is 48. So this purple triangle is isosceles. And you know that the base angles of isosceles triangles are congruent. So angle B, the 80.418, that's this angle, but it's also this angle. So what do you know about angle B2, this obtuse angle? Well, if we can kind of zoom in on this, we've got the 80.418 right here. And we can see that the angle we want, angle B2, forms a nice straight line with it. And straight lines are 180 degrees, just like triangles are. So they're literally called a linear pair from geometry. They're supplementary. They add up to 180. So we get our next answer by remembering that our angle B, and it won't always be called angle B, you'll have to kind of look at your drawing to make sure you're looking at the right named angle. But we'll just do 180 minus the 80.418. Which I guess is going to be 99.582. Okay, great. So that means we just learned a heck of a lot in our little sliver of a green triangle that I'm redrawing. We've still got the given 75-degree angle right here. The angle across from the side across from 75 is 48. So here's 48. The side adjacent to it is 49. And we just learned that angle B right here is 99.582. And that's good news, because now we can find this angle up here. Because if all three angles have to add up to 180, then we just do 180 minus the 75 and the 99, blah, 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 blah. So I'm going to do that in my calculator. Oh, yeah. I lost my answer. Can't get it back. Okay, so it's 180 minus 75 in the other angle. I don't have the full decimal anywhere. That's okay. 3 decimal places is fine. So the 99 point blah, blah, blah. 582. Leaves me with a tiny angle. It's only 5.418 degrees. So finally, we just have to find this short little side down here. It's opposite from that angle we just found. So it's law of sines again. We'll do the sine of the 5.418. That gets divided by the length of side A. And we'll set that equal to the same ratio that's been doing all the work for us, the 48 and the 75. So cross multiply. Here it is. Okay, just hit the buttons on that. We're doing the sine of 4 point blah, blah, blah. Sine of 5.418 times 48 divided by sine of 75. 4.692. So there, you now have your two separate solutions. You've got the orange triangle in which angle B is acute. That's case 1, which has these 3 measurements. And then you've got the green triangle in which angle B is obtuse. That gives you these 3 measurements. And again, the bridge that got us from solution 1 to solution 2 was understanding that the angle B's, the guys down here, were supplementary. So we could find the measure of angle B in triangle 2 by just doing 180 minus the measure of angle B from triangle 1. And that's how that works. That's how this will always work. Moving on. I have 3 minutes and 1 more problem. Okay, maybe my kids can wait. They're at daycare. They'll be fine. Let's solve this. Let's pray it's not a 2 solution, but I'm sure it is. Yeah, it totally is. Okay, sketch it out. La-di-di, 54. This side is 15. So we kind of already know again that I could slide a 13 in this way, or I could slide the 13 out that way. There's my 2 solutions. How do I know that? I know that because I can find this height. That height's going to be 15 times the sine of 54. $12.135. So again, we know that since 12.135, our A value, our A value of 13 is bigger than that. But our A value of 13 is also less than our B value of 15. So that puts us in that sweet spot between those values. That gives us that thing we've been calling case 3, or the ambiguous case. We're going to have 2 solutions. So better hurry up and solve. I told you that we're always going to be solving this triangle first. The one where this angle down here is acute. So who is that angle this time around? I'm not sure. 54 was called A. Why are you so thick? 54 was A. 15 was B. So it's called B again. Great. So C would be up here. So let's get to solving. So we're kind of ignoring this thing for the moment. We've got the 13 and the 54. We've got the 15 and B. So we're going to try to solve for angle B first. So we take the sine of the 54, divide it by 13. Set that equal to the sine of whatever B is, divided by the side opposite from B, which is 15. So the sine of B is going to be 15 times the sine of 54 divided by 13. So do the inverse sign. I'm getting 68.984 degrees. Shoot. Okay, easy. We got B, and we already have A, which means we can now easily get C. C is going to be 180 minus the 54 that we already have, plus the 68 that we just found, 0.984. So just add 54 and subtract it from 180, I'm getting 57.016. And so now to solve for side C, we basically are going to use this exact same setup, right? Oh, I keep pressing this button. I'm going to rip this button off of this pen. It's useless. Okay, so again, we're going to grab that sine of 54 over 13. But this time, we're going to use the sine of angle C, the 57.016, and divide that by C. We're solving for side C. So, okay, that tells me that side C is going to be what? 13 sine 57.016 divided by sine of 54. So hit the buttons and you'll find 13.479. Okay, so there's your solution 1. Now again, looking at our diagram, if we want to work our way over into solution 2, which is going to be this triangle, then we know that our new angle B, B2, is going to be the supplement of B1, right? So that's our little trick again, is we can find the second angle B by subtracting from 180.
I need to go.
Okay, so now to work our way over to case 2, like I said, we can find that the measure of angle B in our second solution is just going to be the supplement of the old angle B. So 68.984. That leaves 111.016. So that's our angle B in solution 2. So that means we solve for C now the exact same way, because we know that the measure of angle C is still going to be 180 minus the angle A and the angle B. Angle A is still 54, but now we're using the new angle B, the 111.016. So that gives me an angle C of, add 54 to this, subtract it from 180, 14.984 degrees. And then to find side C, we're going to set up another sine ratio. So we're still going to use the 13 over 54, or sorry, sine 54 over 13. Although it can go the other way. If for some reason you guys wanted to flip these and do the side in the numerator, you could. Now we're looking for side C. So you know that in the numerator, you'll just be doing the sine of angle C that you just found, 14.984. So cross multiply and you'll get C equals 13 times the sine of 14.984 divided by sine 54. So C is approximately 4.155. So there you go. In column A over here, these three values are your first solution for solution 1. And over here in column B, these three values are the solution for the second triangle. And that concludes our third homework. Hope that was helpful. Come to me with questions tomorrow if it wasn't. Peace.